Okay, part two to keep rolling. So hopefully you have enough to kind of take off on basic derivatives of exponentials. Part two here tells us more about more complicated versions, even natural log and all that kind of stuff. So let's keep rolling. But let's, number 4 is same rules, but we have two product rules. X squared e to the x minus 2x e to the x. Those are products. So I need to treat them with, in purple brackets there, I set up the two product rules, you know. Derivative of the first times the second unchanged plus the derivative of the second times the first unchanged, all that good stuff. So here's how that unfolds. And then of course derivative of 9 e to the x, derivative of e to the x is just e to the x. And the 9, the constant, stays. So there you have derivative of 9 e to the x is 9 e to the x. The product rule pieces, derivative of the first times the second unchanged plus the derivative of the second times the first unchanged. Derivative of e to the x is e to the x. I highlighted that there. First and second unchanged, you know, I did the derivative product rule. I'll let you analyze that on your own. But that's it. We can leave it like that. But it was two product rules, including some derivatives of exponentials. Okay. Rewriting. X over 3 is 1/3 x, so I rewrote it. Slope of a tangent line. That's what we're in here for. Derivatives are to find the slope of the tangent line. So at a given point, well, we have a point. And to get the slope at that point, we need the first derivative to do so. So, whoopsie. I'm sorry, I jumped ahead a little bit there, but I think we should be okay. There's 0, 1. Derivative is the following. I'm sure you've got this down by now. Now, to get the slope, you put the x back in. This is just the derivative. To get the actual slope, you put x in. I'm going to put the 1/3 out front. It's a little more, it's more common to have it there. But there's this 0. E to the 1/3 times 0 is e to the 0, and anything to the 0 is 1. So 1/3 times 1 is where I get the 1/3 for our slope from. Okay, that's the end of the story there, just the slope of the tangent, 1/3. Next, we'll up the ante a little bit. Let's do the slope of the tangent line. Now, I'm sorry, so the equation of the tangent line. Different than the slope, this is the equation itself, which includes you know, y equals something, and then you have x's and various numbers. We're going to use the point slope form to tackle this, and first we got to get, of course, a slope. We need a point. We've got the point. The slope will come from the derivative of the function and put in the x coordinate, and let's roll. Here's our point. Derivative. All right, we can do these now. We got the derivative down, right? And we put our -1 in for x. Then we find our slope. Now, let me tell you about x is -1. -1 to the 7th is -1, and -1 to the 6th is +1. The rule is a negative to an odd is still negative. A negative to an even power is +1. Okay, and now we put all this into y minus y1 times m times x, or equals m times x minus x1. I'm going to add y1 to both sides. That's going to be a good way to just to get whatever y equals. So here's that equation. I'll do that in the next problem as well. But y1 and x1 will just drop in their places. M is the slope. Let me label those for you. We're just going to substitute them into the function. And I wrote it over on the left. Look, it's a direct substitution. 1/e for y1, 7e to the -1 for m, and -1 for x1. Minus a negative that we have there, of course, is a plus. Next piece, same process. Equation of the tangent, 0.04. What we want to do now is get the derivative, and there is something to this derivative. It's a chain rule. So that 2 exponent to the, so whole thing to the second power, bring the 2 out front, reduce the power by 1, leave the inside untouched, then times the derivative of the inside. So I got to go, this is a great time to revisit your chain rule. If you've forgotten, email me, let me know, look at old videos, search on the internet. There's great videos on the chain rule there as well, but let me know how I can help. But we're going to put 0 in to the derivative. So here's what we get. E to the 0 is 1. So a little quick arithmetic, and this is what we get. Okay, that's -16 in total. That's our slope. So derivative, put in the x, find the slope, use the slope and the point in this lovely equation here, drop them into place, and you're going to tell me that this is the equation of that line. Because it's x minus 0 in the parentheses, we can just rewrite this as 14 minus 6x. To the bottom, and again, rewind, fast forward, pause, however you need to do on these videos. Product rule. Now, implicit differentiation is when we do the anytime we take the derivative of a letter that's not x, we write d letter dx. So we're going to have dy dx's because I have some y's in here and I'm taking the derivative with respect to x. The way I just wrote this, by the way, it looks like I'm saying dy dx equals this. It doesn't. I'll cross it out here in a minute. But there is a product rule. X squared y, the derivative of x squared is 2x times y unchanged, plus the derivative of y dy dx times the first x squared unchanged. And then derivative of e to the y is e to the y dy dx. The baby just crawled to the toy. Whoa, good job, Graham. So e to the y dy dx, derivative of -5 is 0, and of course derivative of 0 on the other side is 0. So now the job is, all right, get the dy dx's by themselves. So I just highlighted 2xy on the left. I subtract that from both sides to get towards dy dx being by itself. And then you factor out the dy dx. I literally divide it out front. And if I do that, it leaves me x squared minus e to the y left. So, and then I divide by that on both sides to get dy dx by itself. So there's a lot going on in there, and this is a good one to start pondering and look at other examples of when we did implicit differentiation. It's the same stuff we did before, we're just throwing in this e function. You get dy dx by itself by factoring, you divide both sides by what's left, and we have this nice expression, and we're done. On we go. So now, the next piece is, it says, here's this account balance function, savings account, growing at 6% interest continuously, compounded. But now I'm not asking you to get a value in the account. I'm saying how fast is it changing? How fast is the balance changing? Rate of change is a derivative question. So what we do is we take, if there's a rate of change question at hand, we take the derivative of the function and we plug in values for the particular moments we're interested in the slope or the rate of change. So here's the derivative. I took it 4,000 is a constant, so I kind of ignored it. Took the derivative of e to the 0.06t, which is e to the 0.06t times 0.06. Combine 4,000 times 0.06, got 240. Now I'm ready to put in any t I want, and it asks for t equals 1, 10, and 50, and you get your appropriate values. So the derivative, don't forget, is to calculate rate. That's what it's there for. Now, before we get into the others, log. Natural log is the inverse function of e to the x, the exponential growth function. Inverses are important because they're what the opposite of, they undo it. So multiplication and division, inverses. Squaring and square roots, inverses. Derivatives and integrals, which we'll get into later, those are inverses. They undo each other. So we're going to have to talk about log of x, and I'll explain that more in class. But first, let's take the derivative of it. Pretty easy. Derivative of natural log of x, 1 over x. Okay. The next piece, I would put dx out there, but you guys know that cancels, right? So now, what if it's the log of some function? Let's call it u again. Then it would be the log of u, the derivative would be 1 over u times the derivative of u, written as du dx. Or we could use that prime notation that some of you like, so let's put that in there. The derivative of log of u is 1 over u times u prime. Let's get a u. Okay, u in this case is 2 minus x squared. So the log of 2 minus x squared, so we write 1 over 2 minus x squared times the derivative of 2 minus x squared, which is negative 2x. We're done. You could write that in and be done. Or simplify. Put that negative 2x on top, 2 minus x squared on the bottom. We're done. Let's complicate it a little bit. You know, the function can get more complicated, but the rules don't change. The log of 9 minus x to the 3 halves, I do 1 over that times the derivative of 9 minus x to the 3 halves. And that's a chain rule. So you bring the power out front, subtract 1, leave the inside untouched. That's 9 minus x. Then you take the derivative of 9 minus x, which is negative 1. So now we've got the insides I underlined, inside, derivative of the inside. It's a great chain rule. So that's, remember, the part on the right is the derivative of 9 minus x to the 3 halves using the chain rule. 3 halves out front, subtract 1 from 3 halves, it's 1 half. Leave the inside, 9 minus x untouched, times the derivative of 9 minus x, which is negative 1. So again, go back and check out your chain rule if need be, whatever it does, whatever you need to help in your situation. Okay, so on we go. Inside, derivative of the inside. Y prime in this next one, same thing. This is a chain rule from the beginning. I just wrote this one out for those of you who have the idea. This is log of x to the fifth to the second. Well, I need to do a chain rule because it's something to a second power. So I do the 2 out front, subtract 1 from it, leave the inside log of x to the fifth untouched, and then next to you'll see the derivative of log of x to the fifth, which is 1 over x to the fifth times the derivative of that x to the fifth, 5x to the fourth. So there's a couple components. There's altogether, it's a chain rule to start with. And then the inside, when we get to taking the derivative of log of x to the fifth at the end, that itself, we have to use this new log rule, which is derivative of log of something is 1 over something times the derivative of that something. So here's the 1 over something times the derivative of that something, that log of x to the fifth. Okay, so that's done, by the way. You can leave it simplified if you want, but for now, just kind of get the idea. Let that sink in for you. 13 is a rewrite. I'll go quickly through that, and then let's say that'd be a good one to check out in class if you can't get it looking at this. But the basic idea is you want to write that as log of x times x to the negative third, and then it's a product rule. So you want to do derivative of log of x times x to the negative 1/3 plus the derivative of x to the 1/3 times log of x. And I'll let you fill those blanks in. That's it. Email with questions. That should get you through most of it, and the rest maybe email me, search some things out, just kind of get to your resources, and we'll pick up at a pretty quick clip on Monday. Take care.